Good afternoon, ladies and gentlemen. Let's take a long look at this problem from 2013, AP-AB. This is problem number 2, and this is going to be a total amount problem. Keep in mind, we are going to be allowed to use a graphing calculator on this problem, and that's going to be huge. The first one we want to do is critically read the problem stem. This is the problem stem here. And it's going to be advisable to, before we jump into the different parts of the problem, we're going to come up with a total amount function, because this is definitely a total amount problem. So let's jump into the problem stem. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by this G of t, which is equal to 90 plus 45 cosine t squared divided by 18. Here we have t measured in hours, and we're looking at t from 0 to 8. At the beginning of the workday, t equals 0, the plant has 500 tons of unprocessed gravel. During the hours of operation, between 0 and 8, the plant processes gravel at a constant rate of 100 tons per hour. Let's critically read what's going on here with this problem. First thing we need to notice, and we're going to circle some things or underline some things, the rate in tons per hour that gravel arrives at a plant. So we have the rate in tons per hour that gravel arrives at a plant is given by this G of t. This is going to be important. So this is the rate that gravel arrives at this processing. This is a plant that processes gravel. And if we're going to process gravel, we need gravel to come into the plant. And we note that the plant is only open 8 hours a day. What else we need to realize is that at t equals 0, the plant has 500 tons of unprocessed gravel. That's going to be important. At the beginning of the day, they have 500 tons of unprocessed gravel. This is a very efficient plant because the last thing we notice in the problem stem, that during the hours of operation, 0 to 8, the plant processes gravel at a constant rate. They process gravel at a constant rate of 100. So we're going to use those three facts, and we're going to come up with a total amount function. And the total amount function is going to be the total amount of unprocessed gravel at the plant at any time t. And this is going to be very important that we realize what a total amount is. There are several problems that are presented year to year about total amount. So let's jump in and come up with the total amount of unprocessed gravel. The total amount of unprocessed gravel, we're going to let it be A of t. Let this rascal be A of t. And what is the total amount? Well, it's going to be the initial amount of gravel at the beginning of the workday plus the amount of gravel plus the amount of gravel that arrives, i.e. the rate in, sometimes we're going to call this the rate in, minus the rate out. How much, in context of this problem, it's the rate that gravel arrives at the plant, which we saw was G of t in the problem stem, and the rate that gravel is being processed, and that's this 100 thing. So this is the total amount of unprocessed gravel at the plant at any time t. 500, which was the initial amount, plus we're integrating the rate, that gives us the amount. Integrate a rate, you get an amount of unprocessed gravel that arrives at the plant, and then we're going to integrate the rate that we are processing that gravel. That's how much gravel is being processed. So we're going to subtract that from the total amount of unprocessed gravel. So this is our total amount function. And right away, we're going to hey, let's find A prime of t, which is equal to G of t minus 100. And this is true because of the fundamental theorem of calculus. Fundamental theorem of calculus, whatever part you want to call it. But if you differentiate a rate, you get an amount. Differentiate a rate, you get an amount. And A prime of T is the rate the amount of unprocessed gravel is changing. This is going to be very important. Every problem is going to talk about the rate that total amount of something changes, because this is a calculus class. And as a side note here, we're going to say if A prime of T is less than 0, A of T is decreasing. In like manner, if A prime of T is greater than 0, the amount is increasing. And this is what the derivative tells us about a function. This is the same stuff that we've talked about for a long time since first talking about derivative. So this is going to be a very important, and I want you, what I would like for you, my students, to do every time you see a total amount, a type of problem that gives a total amount, what I want you to do is come up with a total amount function, and right away comes up with the derivative. You're going to use that in every problem somewhere. And right here, we're not really going to use that until part C and D, but that's okay. So we will use it. Let's go to the next slide then, and let's deal with parts A and B. Parts A and B only deal with this creature G of T, which is the rate unprocessed gravel arrives at the plant. This is the rate that unprocessed gravel arrives at the plant. And right off the get-go, they say, hey, what's G prime of 5? What's G prime of 5? By our calculator, keep in mind, one of the very first statements we made was this was a calculator problem. Do not, by any means at all, try to analytically find G prime. You're wasting time. You put G into your calculator. Put this G into your calculator. Put that dude in your calculator, and use your calculator to find G prime of 5. If you do that, you will see that G prime of 5 is this negative 24.588. What we need to do is make a decision what this negative 24.588 means. Well, let's just right off the get-go, this is the rate. G of T gives us the rate that unprocessed gravel arrives. Let's see, G of T gives us the rate that unprocessed gravel arrives. So this statement here is going to tell us the rate of gravel, the rate gravel is arriving, is decreasing by this amount right here, by this amount of 24.588. What I have to do is come up with the units for 24.588. And this gets a little bit tricky for lots of calculus students. The rate of this G prime is tons per hour per hour. And why is that true? For a brief little explanation of why that is true, we've talked about that in class before. If I look at the graph of G of T, more importantly, and this is what the graph of G of T should look like. So that's a good thing that you might make sure that you're looking at G of T in your calculator, because this is what it should look like. But if I look at that, and more importantly, look at the units of G of T, in the units of G of T, this rate were tons per hour. The output of G of T was tons per hour. The output goes on the vertical. The input is hours. So therefore, anytime you have the units of the derivative are always going to be the units of the vertical divided by the units of the horizontal. So that's going to be valuable information. Whether you understand what tons per hour means or not, you can come up with the units knowing that the units of the derivative are the units of the vertical divided by the units of the horizontal. That's where this tons per hour. So G prime of 5, negative 24.588. What does this mean? This means the rate gravel is arriving is decreasing by 24.588 tons per hour. Let's continue that, and let's do the easiest 2 points in this problem are going to be coming from part B. And part B said, hey, find the total amount of unprocessed gravel that arrives during the hours of operation. Well, the plant operates from 0 to 8. So to find the answer to B, all I need to do is set up the definite interval from 0 to 8 of G of T. You integrate a rate, you get an amount. And I'm integrating this bad boy from the time the plant opens to the time the plant starts. That says that the plant has processed 825.551 tons of gravel. And again, this whole units thing, this is why if you integrate a rate, you get an amount. The units of the definite interval are going to be the units of the vertical times the units of the horizontal, tons per hour. This was the units of the vertical, times hour, the units of the horizontal, tons per hour is tons. That's why if you integrate this rate, you get an amount. Rate tons per hour. It's going to give us, you integrate this rate, it gives us tons. So that's a very, very easy 2 points for this particular problem. Let's jump back up to the problem and see what part C wants. Part C wants, hey, is the amount of unprocessed gravel, is the amount, check this out, is the amount of unprocessed gravel increasing or decreasing at T equals 5? Show the work that leads to your solution. Hey, what about this right here? Wouldn't it be nice, and it would be, to have this total amount function, to have the derivative of the total amount function, because that right away tells me to rate the amount of unprocessed gravel is changing. And right here I said, hey, if A prime is less than 0, the amount is decreasing. If A prime is greater than 0, the amount is increasing. So let's go back to where I've solved this particular part of the problem right here. And I'm using that total amount function. And here again, I review the fact that if A prime of 5 is less than 0, the amount of unprocessed gravel is decreasing. If A prime of 5 is greater, then it is increasing. So let's find A prime of 5. And I've already calculated A prime, which is G of T minus 100. Keep in mind, I have G of T in my calculator, ladies and gentlemen. So all I need to do is find A prime of 5 is to find G of 5, subtract from it 100. And if I see that G of 5 is 98.140764 minus 100, and I know that rascal is certainly going to be a negative number. So what does that tell me? That tells me, golly, that the amount of unprocessed gravel is decreasing at the plant at T equals 5. That's what A prime of 5 is equal to, and the work that leads to that solution is this guy right here, A prime. It would be nice if you have A of T. Look at part D of the problem stem. Part D of the problem stem asks me, what is the maximum amount of unprocessed gravel at the plant during the hours of operation? Justify your answer. Well, what I want is the maximum amount of unprocessed gravel. I have this function here that gives me the total amount of unprocessed gravel, and this is that function right here. And I want to know when that is a max. Well, and I'm only talking about during a workday. During a workday. Well, during a workday, the plant is only open from 0 to 8. So to get that max, let's jump back to the last screen. There's the maximum amount. The max is going to occur at the beginning of the day, T equals 0, or at the end of the day, T equals 8, or when A prime of T is equal to 0. Keep in mind, this could be a min or a max. But that's how, if you recall, again, from our days of analyzing functions based on their derivatives, a function has a min or a max when the derivative is 0. They are wanting you, the question writers are wanting you to write this statement here. They want you to say, hey, if a prime of t is equal to 0, max is going to happen there. Well, we know what a prime of t is. That's at g of t minus 100. I have g of t in my calculator. I'm going to solve this equation in my calculator, and this is going to tell me that a prime of t is equal to 0 when t is equal to this. We don't round. We want to round to the very end. So that's when a prime of t is equal to 0. This is a critical value of the function. It's critical. So we have 3 spots where the maximum amount of gravel could happen. We have to check all 3 to get the points for this particular problem. The maximum could happen at the beginning of the day, at the end of the day, or this critical value that we found where a prime of t was equal to 0. So I have 3 values that I need to test. Some teachers call this the endpoint test. This could be the extreme value theorem test, or this could just be the common sense test. So I have my total amount. This is going to be very nice because I have my total amount function, and I'm simply going to find these 3 different values. I'm going to find a of 0, a of the critical value, and a of 8. Well, except that this is, I need to erase this because this is the work for a of the critical value. A of 0 is going to be easy to find because at the beginning of the day, how much of the gravel is there? 500. No gravel has arrived. No gravel has arrived, and I haven't processed any gravel yet because it's the beginning of the day. So I know a of 0 is going to be 500. But I need that value. Seems silly, but it really doesn't because I have to check the endpoints. That could be the maximum amount of unprocessed gravel. It's at the beginning of the day. So I need this value that's associated with a of 0. Now I'm going to find this total amount of this critical value that I found, this 4.92340, and I simply put that into my total amount function. It's going to be 500, and I'm going to integrate g of t from 0 to that critical value. I could put that critical value into my calculator, store it, and just go from 0 to that particular stored value, so I don't have to keep re-entering that in my calculator. And I'm going to subtract from it, and I'm going to graph this constant function of 100. With this, it's just going to be a rectangle from 0 to 4.23480 times 100. So I'm going to find this, ladies and gentlemen. Make sure you use your calculator again to find that amount of gravel that has arrived from 0 to the critical value. And if I add these numbers up, this is going to give me 635.376 tons. This is the total amount of gravel associated with the critical value. And the last thing I have to do is I have to check at the endpoint a of 0 at the end of the day. At the end of the day, how much unprocessed gravel do I have at the plant? So I'm going to find a of 8, and a of 8 is going to be 500 plus 0 to 8 of g of t, minus from 0 to 8, 100. Again, this is just going to be a rectangle, which is going to be 800. This, I have already found this value earlier in my problem. So what is this? Here is the amount of unprocessed gravel at the end of the day. And what did the question ask for? The question asked for, let me zoom in here and get a good look at the whole problem that I've done. Gives me a good problem, good picture of it. The problem asked for the maximum amount of unprocessed gravel during the day. Well, if I'm going to look at these 3 values here. I have this value, and this value, and I can see the maximum number is this 635. So that's going to be the maximum amount of unprocessed gravel is 635.376 tons. This max amount happens at t equals 4.9234. So this is a very nice, long, detailed solution of this particular problem. There's lots of problems similar to this on each of the AP exams each year. Go back to that problem. Go back to the very first problem. And when I originally look at this problem, it looks somewhat intimidating. My advice to you would be, do not be intimidated by this problem. Critically read a problem of this nature. Make your connections as we have done. Come up with your total amount function and do some calculus. Good luck, ladies and gentlemen.